Good morning. I'm Krista Campbell. Thank you for joining us today for Increasing the Flow in Fire Hydrant Maintenance. In today's webinar, you will learn how Bowling Green Municipal Utilities moved from a paper-based hydrant maintenance program to a digital map-based process that allows them to track the progress of work being done, provide up-to-date flow data to users, and summarize data for decision makers. Joining me from Bowling Green Municipal Utilities is Becky Brown, GIS Administrator, and Andy Johnston, Fire Hydrant Maintenance Technician. They're going to share why they started using GIS, how each of them transitioned their work, and what's next. I hope you enjoy the webinar. Today's topics: daily workflows, replacing paper processes, and then Bowling Green Municipal Utilities will share their story of moving to a digital-based workflow. We're going to kick off with a poll. If you would take a few seconds to answer the poll, I would appreciate it. Do you still have paper-based workflows? Yes, no, yes, but transitioning to digital. It looks like about half of you are transitioning to digital, and the remaining audience is split between yes and no. I'm going to spend a few minutes talking about workflows. Take a look at this diagram. I think this is a great reference. It gives a quick view of what parts of the ArcGIS platform can be used for each step of a field workflow. Plan your work using desktop or online, coordinate field work with workforce, or in some cases, a CMMS is used. Navigate to work locations using Navigator. If you're not familiar with Navigator, it's pretty cool because it's an app that allows you to navigate to your asset. You don't have to use an address. Capture using Collector or Survey 123. Collecting field data with these applications are pretty easy. And monitor. Use Operations Dashboard to keep track of work that is being completed. Not every part of this diagram is required, and there are solutions, other parts of this ArcGIS platform that are not shown. Utilities that I've worked with have implemented different pieces of this workflow, and it's not an all or nothing thing. You implement what you need to complete the specific workflow. I'd like to share two examples focused on valve exercising and meter changeouts. Henry County Water Authority had a paper-based workflow for their valve exercising program. Each day the foreman mapped out work areas, the crews traveled to their sites, and then completed a paper form that had 22 fields on it. They did this for each inspection. At the end of the day, the forms were counted and used to keep track of monthly totals, and then the information on each form was manually entered into a database. The paper forms were difficult to manage and sometimes data was lost. Because of the high number of inline valves requiring inspection, this workflow was identified as a good candidate to move from paper to digital. Staff wanted to eliminate the manual process of using the paper forms, and they wanted to eliminate the data entry. So they checked out mobile applications and out-of-the-box solutions. They made some adjustments to get the new process in place, but by adopting ArcGIS solutions, they were able to quickly access and collect data in the field, see what inspections had been completed in real time, and review workload to plan for the future. This significantly increased their efficiency. A similar example, but with a different workflow, is rural Lorraine County's digital transformation of their meter changeout program. They also used a paper-based process, and they began reviewing this process when a meter changeout program was developed to replace 19,000 meters. This program had the potential for creating a backlog of work orders waiting to be entered into their billing system, as well as making the tracking of progress of 19,000 meter changeouts pretty difficult. Using digital applications to support their meter changeout program saved hours of manual data entry. It also allowed them to collect, visualize, and share information using web maps and dashboards. Management was able to receive up-to-the-minute progress reports of the field crews and provide easy-to-understand updates to their board of directors. They also increased efficiency. Bowling Green Municipal Utilities has transitioned their fire hydrant maintenance from paper to digital. This slide looks similar to the others, but we are lucky enough to have them here today to tell their story. But before we get there, I have one more poll. Do you use any of the following applications to support digital workflows? ArcGIS Online, Collector for ArcGIS, Workforce for ArcGIS, Operations Dashboard, and Explorer for ArcGIS. Great. Wow, it looks like you guys are using a lot of these applications. Not surprisingly, Collector's very popular. Thank you for answering the poll. Now we're going to go ahead and welcome Becky and Andy to the webinar. Becky?
Thank you, Krista, for having us. And I'll just reintroduce myself. I'm Becky Brown, the GIS Administrator here at Bowling Green Municipal Utilities in the Water Wastewater Division. And as she said, Tabitha couldn't be with us today. She really was excited to help present in this, and she's a big part of this workflow. So I'll try to do her part justice, and I'll let Andy introduce himself.
My name's Andrew Johnson. Been at BGMU for 23 years. Fire hydrant maintenance technician, and good to be here.
So today we are going to talk about just how moving into Esri has really helped to improve our hydrant maintenance workflows and move us away from a paper-based system to where it is now. And I'm just going to give you a little background on BGMU. So we are a multi-service utility. We provide water, wastewater, electric, and fiber services to the Bowling Green, Kentucky vicinity. We maintain about 290 miles of water mains and 270 miles of wastewater mains. Our water treatment plant on average treats about 30 million gallons per day, and our wastewater plant treats about 12 million gallons per day on average. We also, in our accounting system, account for about 23,000 active water meters, and we maintain roughly 2,380 fire hydrants. Now, on our water wastewater crews, we have about 25 full-time crew members, and of course, Tabitha makes 26. And out of that 26, we only have Andy, our one fire hydrant maintenance technician, who manages all of the fire hydrants in the system. So where we were about 3 years ago, and historically, for about 20 years, BGMU was in a strictly AutoCAD environment. So we had a lot of limitations on what we could make available to the crews in the field, only able to provide them one online map, and it only had attribute editing capabilities. And you can see it there in the background, hopefully. And it was also a cumbersome process to retain usable historical data, so that fire hydrant historical data was preserved in comment fields, and so it was not queryable. And also transferring the data from the field back into the office was also an additional challenge. So oftentimes those system improvements like fire hydrant installations or even a water main extension would oftentimes pass over employees' desks and then never make it onto the map. We tried to close that communication gap in different ways, but nothing really seemed to stick because it was paper-based, basically. Even with this online map available, it was difficult for the crew members to access it sometimes. So they oftentimes relied on their large format paper copies in their trucks, which I'm sure if you all are in a paper-based system, you're familiar with, damages that happen, the paper gets lost. So there was a lot of reprinting of the maps, and oftentimes it was always outdated information anyway. So we had limited analytical capabilities with AutoCAD, and if anybody wanted to use their specific map, that was oftentimes only available as a paper copy. So we could only present a static information, and it was just a cumbersome process. And it was also impossible for us in the AutoCAD environment to maintain the GIS as a system of record because we couldn't retain historical data. And we just needed a better way of operating that would satisfy all those requirements. So in December of 2015, our engineering department purchased the Esri Small Utility ELA and the Esri Enterprise Advantage program. And then within 1 year's time, our database was migrated from Oracle into a local government information model in our SQL server. And our ArcGIS Online organization was launched with multiple maps made available to crews almost immediately. So our next steps in the process were to implement those user-specific applications, in particular, the hydrant maintenance inspection solution. So in spring of 2017, after the database migration, the fire hydrant maintenance inspections map was launched in Collector. So now crews were able to generate new inspections on hydrants, and GIS was still able to maintain historical records through a related table. There's now viable information to track. We were able to track hydrants requiring paint, hydrants that were flagged as out of service, historical flow data, and those frequency of tests. So, since there's an issue with labeling that's not supported in Collector's current version, we did a little workaround to force labels to display using map services and embedding that as part of the base map. But in Collector's Aurora project, this is a non-issue, and we're looking forward to being able to upgrade our guys to it in the next year. So after a couple of those one-on-one training sessions, Andy was quickly able to pick up on the new workflow, and he was really up and running in no time. This map saves him a lot of time by allowing quick data entry right there in the field at the hydrant. He no longer has to do double entry by writing it on an inspection paper copy and then later entering the data in the work order electronic form. And then in turn saves us time in GIS, where in years past we had to dig through the work orders to find flushing data. We also had to rely on all those stacks of inspection forms to make it back up to engineering for data entry into those correct attribute fields. So GIS still had another issue to resolve after we moved to the hydrant solution. We need to be able to get that recent flow test data from the related record to its corresponding hydrant feature attribute table. This was going to be critical if we wanted to easily analyze current flow data across the system or extract patterns in the data. And we also wanted this information accessible to our decision makers through operations dashboard, and then available at a click of a button on the ArcGIS Online maps and applications. So we found that solution with our partner, True North Geographic Technologies, Inc. They're also an Esri partner, and we hired them to migrate our data to the LGIM. And they graciously shared that Python script that would provide exactly what we needed. And we realized this probably could have been handled a multitude of ways, including GeoEvent Server, but we weren't set up to do that yet, and we needed this data almost immediately. So this script runs about every 15 minutes, and it monitors the hydrant inspection related table for those new updates. And based on the most recent test, which you can see based on this last service date, that moves the data for the static PSI, the residual, and the GPM to populate in the hydrant feature class. So then at a click of a button on our water distribution map, anybody in dispatch or our engineering group can easily access current data. And it's easily accessible in the field also. So with all this wealth of data that we're receiving through the maps, we needed a way to visualize that, and that was through Operations Dashboard. So previously, we had basically no way to display this system data easily or efficiently, and we wanted to be able to provide this to our managers and our crews, and Operations Dashboard has been a great fit for that. And Tabitha was going to demonstrate that, but I'll take her place in that after Andy's presentation. And there are the multitude of information that we can display includes displaying the average system PSI, which you see up here in the top left, and that can be filtered by the hydrant pressure zone, which I don't know if you can see the filter, but it's up here. So we have 4 different pressure zones: central, central, south, north, and east. And that changes, that filter changes basically all the infographics here. We can present the pressure data graphically, as you can see in the bottom, and that also changes as you zoom in and out of the map. We can track the latest flow tests in the list or on the map and get a quick glance view of all the out-of-service hydrants. And as I said before, you can filter the maps and infographics by the pressure zone. And you can also monitor the incoming tests for data inaccuracies. So since this is updated every 15 minutes, Tabitha can easily see what hydrants may need to be retested, either for data input errors or just retesting low GPM hydrants to see if there's an issue that we need to investigate further. So with Workforce for ArcGIS, another Esri application, we found that this would be a good fit for our spring and fall flushing programs for water quality. And this flushing program was put together in the mid-90s. Our team at the time, they looked at our whole system and tried to put up a directional flushing program. And it was all paper-based, and it had been paper-based until this year. And this program we run every 4 years or so. And it serves dual purposes, being able to flush our entire system for water quality. But at the same time, we can gather flow data information and keep that up to date in our system as well. Since this was in a paper process, our crews were handed maybe 70 pages worth of hydrant data. And as I said before, this was just a very antiquated paper process. And so with paper, there was oftentimes a duplication of effort. Sometimes the hydrants were repeated on multiple different pages. The crews wouldn't know where each other were in a geographic relationship, and they would do they would test the hydrant maybe multiple times during the program. And as I said, the data is very outdated. Since in the mid-90s, we've had a lot of development. There have been hydrants added. There's also been hydrants removed, and that wasn't really tracked in this separate paper process. And of course, since we're working with paper, oftentimes those pages would get lost or damaged, and the writing may be illegible. So it was hard for us to enter that data properly. And now with the assignments in Workforce, as you can see right here on the left side of the screen, the crew members are assigned a specific assignment, and so there's no overlap or duplication. There is visibility of each crew member in the field for us and for the crew members themselves, so they can see where each other are. And the assignments that are created right on top of our hydrant feature class, so we don't miss any of those hydrants, and we can get every single hydrant in our system over a period of a year. And then the fire hydrant data is inputted directly into the system, so there's no shuffling of paper. And some of the monetary benefits we realized, and I don't have any exact hard numbers on this, but because you can visually see a group of fire hydrants that are assigned to a specific user, you can just work within that targeted area. Previously in the paper system, they were just going by the list. So that may jump them 3 streets over and then back another 5 blocks, you know, so they were bouncing back and forth, and it was very inefficient. So there was a lot of extra fuel being used. But now, with them being able to work in a targeted area, it helps reduce that fuel consumption. And then in turn, with the reduction of paper and the direct data entry into the hydrant maps, it saves GIS time because we're not sitting there spending 80 to 100 hours of data entry from those paper copies. And some of the other benefits we realized just with Workforce itself, there's just this ease of navigating the workflows, and the assignments are listed all out in front of you. And you can see who's been assigned what. And as I said before, there's that visibility of the mobile workers in the field. And then there's the ease of the app integration. So with the click of a button, I was able to link our workforce program directly to our collector map for data entry. And we can also monitor the life cycle of the assignments from cradle to grave. Also, that data from the assignments is retained in hosted feature services, so we can easily consume that in other places, such as the dashboard. So I'm going to hand this over to Andy so he can demo what he does in the field and talk about a little bit about how his experience was moving from paper to what he's doing now. So I'll hand it over to Andy.
Hi, everyone. Glad to be here. To touch on what Becky said, you know, I've been here 23 years, worked out in the field on fire hydrants, and what I love about this new system, it takes out all the guesswork. It creates a lot less chaos. You know, years ago, they would give me sheets of paper by zones, or if I had to go do flow tests for fire protection or whatever the case may be, they'd give me an address, and a lot of times it would be a factory, and I'd pull up, you know, of course there'd be 4 or 5 hydrants around this factory. Of course, I'd have to get out the paper maps, take 20 minutes to try to figure out which exact hydrant they wanted me to flow test. With this new system, you can enter it right in and punch a button. It takes you right to it. There's no guesswork, and there's no way you can do the wrong hydrant. It's just a great system. You can click on like this hydrant here, you can click on it, start your assignment, collect your assignment, and it takes you right to the hydrant, 1209 Cedarwood Way. You click on the hydrant, and of course it's got the address. It also, you know, it'll you can click on it and it'll tell you if it's out of service or not. I'll get out, do my flow test, do my flushing. Then when I'm ready to enter the information, like I already done this hydrant this morning, so here I'll hit on the field crew, which got a list of people that sometimes works out in the field. In this case, it's me. I'll click on my name and enter the static, which is 58 in this case. The residual pressure is 28. And the flow rating, GPM, is 980. And I flowed this hydrant for approximately 6 minutes. And that also helps keep track of our water loss. We have a water loss team. They try to keep count of all the water that we flush, that we use water loss during the months, and where they can report on it. Hit the test date when I tested this hydrant, which was today. Then you would submit that hydrant, and within a matter of 15 minutes, this information is uploaded. And when you hit finish, it takes that off to your list. There's no chance of anybody else doing it. If you've got 2 or 3 crews, like Becky said out there, each one's got a specific task. There's no chance of overlapping, maybe stirring up the water system, getting complaints. Used to, when we was doing paper, there was a chance each one would get over in each other's zone, and you know, we had a lot of problems stirring the water system up, which we would have a lot of customer complaints. This system saves a lot of that. We don't have near the customer complaints that we did in the past, because you can actually see where your dead end hydrants are at. If you flow test one upstream, maybe I can draw one up on the map here and let you look at what I'm talking about, where you can see. Okay, just like if I was testing this hydrant right here, and if I flow tested that one, after I got done, I know I'd need to come down here at this end cul-de-sac and flow test that hydrant. Because if not, I would stir the water up between the hydrant that I last flow tested to the dead end hydrant down there in the cul-de-sac. It just saves you so much time. It takes out all the guesswork, creates a lot less chaos. Also, it has a edit, like if you go out, we have a lot of hydrants that's hit during the nighttime, cars hits them. A lot of them is not reported. We go out a lot of times and we go to test one, and of course the breakaway flange is broke or whatever the case may be, it's been hit by a car. We've got capabilities where we can go in here and edit that hydrant, put it out of service. That way we can go ahead and call a work order in. That way the fire department, everybody knows that it's out of service in case we have a fire in the area. But it also gives me a chance to actually create a work order where I can have that hydrant fixed, in a few days when I get time. But this system, I really like it after filling out work orders. Used to, we had to order, I've had to write stuff down out in the field. Sometimes I'd have to do it twice. I'd get in the afternoon. If I did 15 hydrants that day, that's to add, put 15 different tests into a work order on the computer, which took a lot of time. Now I can do it out in the field, and I'm done with that assignment. And it saves the company so much time, like Becky said, fuel consumption, because when you complete that hydrant, the next one it gives you is the closest hydrant to you. You don't have to worry about going 34 blocks over doing one and then having to come right back to the same area. So it's a great system. I highly recommend it.
Well, thank you, Andy. And Andy's really been our, I hate to say it, poster child on the use of this system. And he's right, it's just, it takes out all the guesswork, and it's just easy to navigate between workforce and collector and then back to your next assignment. And Tabitha, she's an integral part of the workforce project. She'll do the assignments during the day, and she'll just pick a cluster of hydrants to send down to Andy, so he doesn't have to wonder where he's going next. It's all just handled for him, and he can just focus on providing good customer service by not messing up the system and keeping the system clean and flowing well. And just to touch back on the initial setup of the workforce project, with the schema that Esri provides on the assignments, that made it easy for entering that data into workforce. So we have, as I said, over 2,300 hydrants that we had to create assignments on. We have a separate spring flushing schedule and then a fall flushing schedule. And so each of them have about 1,000 or more hydrants assigned to them. And so at first we started the process by creating individual assignments, and then I realized that was just a bad way to go about it. I downloaded the schema for the assignments, set up our hydrants to reflect that schema, and just uploaded it. And I had all my assignments created instantaneously. So it was very handy. And then also with the operations dashboard, which I'm going to show next, that really reflects well on Andy and gives visibility to our managers and his supervisors on the work that he's doing out in the field. Whereas before, it was all covered through paper. There was no, we didn't have GPS tracking on the trucks. Nobody's really monitoring what's going on. So it's just by, trusting the person that he's doing what he says he's doing. And now that's really reflected in this dashboard and reflects well on Andy and his efforts. We I consumed the assignment data, as you can see here in this map. So through these concentric circles, you can see the latest tests that Andy's been doing. You can see the areas where he's been last. You can see how the circles go from small to larger, so you see the areas that he's flushed. And then also, I have this PSI map, so this tracks where our static numbers, and it's all categorized by basically no data all the way up to these outliers, which these are numbers we're trying to get rid of in the system. But it gives you an idea of what's going on out there. And then as I zoom in, you see the list change and the graph changes down below as I pan around. And then also we have this GPM map, which reflects the current gallons per minute that are inputted in the system. And also up here at the top, we were able to create a filter for the whole dashboard. So as I said before, we have these 4 pressure zones. So I can look at central pressure zone, which changes the data that you see here. It also changes this map. I'm going to zoom out so you can see it. We'll just change these filters so you can see how they change everything else around. So I can zoom in on an area. I can filter this graph down to see finer detail about the static and residual pressures. As I said before, the filter also changes this average system PSI number. So we can look at the whole system as a whole, and we can drill down and get finer detail about each pressure zone. So it's very customizable, very user-friendly. And I'll touch back on Tabitha's part of this. So she didn't really have any involvement in the fire hydrant maintenance program before. She would receive Andy's inspection forms, paper copies, and just transport those from crews back into engineering for data entries. So there was always a delay in entering that data just because we're relying on paper. But when we moved over to this system, she had this dashboard just right at her fingertips. So she worked very closely with the crew supervisor and the assistant crew supervisor, providing them information about what's going on in the field, and she can do it easily through this dashboard. She can see all the new tests that are required. So we have all these hydrants that have been added to the system, or we just discovered through field inspections that we needed to add into our GIS. She can also see the latest tests and see the data coming through on those latest tests. She can also view quickly those hydrants that have low GPM. So we have to revisit those hydrants, and she'll create a new workforce assignment. The assignment type's called just retest, because we want to try to figure out, was that just a bad test, or was there a pump on when he was doing the test, or is there actually a valve closed that shouldn't be closed? So it helps us further investigate those problem areas. And then we can quickly view all of our out of service hydrants, and then also those hydrants that need paint. So she'll have to create a new work order for those hydrants for Andy, so he receives those work orders through our CIS system, iView. And I also added a link so she can just open iView directly from here, which I don't have iView loaded on this laptop, otherwise I'd demonstrate it for you. And then also she can go up here and just see a quick view of all the tests that Andy's performed this week, and then just a snapshot of the out of service hydrants. So this is really user friendly, and as I said before, customizable dashboard. And since I also want to touch base back on the script too. So we have it set at a 15-minute interval, and we can just change that through Windows Task Scheduler. Maybe in the future we'll probably start utilizing maybe GeoEvent to populate some of that data. And now I'm going to touch base back on what's next for our fire hydrant maintenance program. So I embedded that link for her to hop back from from the dashboard to iView to open up a work order, but we also want to do that direct hop from what hydrants need to be retested because of low GPMs from dashboard to workforce, so she can create those retest assignments. We're also looking forward to be able to start doing some analysis on the data that's coming in. We've got about a year and a half worth of data that Andy's collected out in the system. Some other endeavors, we hope to collaborate with our city, specifically the 911 services, so we can allow them direct access to our REST site for the hydrant data. Our fire department is equipped with laptops. They also have access to their ArcGIS Online organizations, so this should be an easy partnership that we'll be able to fulfill. Right now, we send them a shapefile export periodically, just whenever they request it. So the data is it's basically old data, and just being able to give them visibility of current flow data and those hydrants that are currently out of service will be a big advantage to fostering that communication between our departments. We also, since we report flow data and residuals and everything to engineering firms, we also report that information on request to fire protection services. For a new development that may be coming in, they'll want to know static and residual and GPM and the latest test date. So in order to make that easier, I want to take our current PDF form and transition that into a Survey 123 form and just have it as a direct link in our water distribution dashboard. So, in our map. So where people in GIS and engineering can just click on a button, fill out the form, and email it to the requester. We are also working on maybe a water loss operations dashboard. So right now we have a field for water loss in that hydrant inspection form, and we want that just to be an automatic process. So it'll do automatic calculations and it'll do automatic reporting, so we can quickly display that in the operations dashboard. We're also looking forward to work order integration with our current CIS system, and through that, crews will be using a Survey 123 form and can enter water loss data directly in there, and that can be displayed on a water loss dashboard for our water accountability team. So I think I've touched on all the areas that we wanted to talk on today, and I just want to thank you all for listening, and thank you, Esri, for this opportunity for us to share what's going on here at BGMU, and we just look forward to all the further enhancements and capabilities that Esri's applications are going to afford us. Thank you.
Thanks, Becky and Andy. We're going to move to our Q&A now, and we do have several questions that have come in. Becky and Andy, there is a question about implementing this new workflow, and I know Andy spoke and he really liked it and it's working well for him, but did you face any challenges with others in this transition?
Well, Christy, you broke up a little bit on the question. Do you care to repeat it?
Sure. Did you face any challenges with other team members implementing this new digital workflow? We talked to Andy and it seems like he's really on board and likes it, but was there a training process or challenges bringing other people into the workflow?
Oh, yes. And with any big change like this, moving away from paper to electronic format, there's always going to be some pushback. And usually that just comes from, this is the way we've always done it. Why do we need to change things? And I think every utility, or basically any industry facing that is going to hear that. And I think we've tried to push through that and make a change just by doing a lot of the one-on-one training with everyone. We've met with everyone just as a large group, but we're trying to do focus one-on-one training sessions. And those are oftentimes a continual process. We'll probably be doing that again this fall, meeting with the guys that maybe need further encouragement or assistance in learning how to use the tools. And a lot of the work to close that gap comes from management, and it's really management enforcing that, yeah, we're looking at these dashboards, we're looking at this information, and if you're not putting it in there, then we can't see it. And I feel like, especially in Andy's case, you know, it really advocates for the work that he is doing. So yeah, he knows that crew supervisor and managers are looking at this information, and it makes it easy for him to convey that to them. So it really does him a great service to be able to do that.
Also, to touch on what Becky said, this new system, it's not only for fire hydrants. You can actually blow it up and see the water lines, what size they are, what they're made of. You can see the valves. You know, I'm on water standby every 6 weeks. We're out all hours of the night. It helps in water break situations. I mean, you used to, it would take you 30 minutes to look up what would shut the valve off in this city block, shut that main off where you could repair that main. Now you can pull it up on this system, takes you right to it. The valves are even shot in GPS. I mean, it'll take you within a foot of the valve in case the valve is buried. So, you know, it's bulletproof. I really like this system.
Thanks, you guys. Our next question is about your data. Are you storing this in the cloud in ArcGIS Online, or are you using a server?
Yeah, so we host all of our data locally on our servers, and just publish through that through WebAdapter up to ArcGIS Online. There's a very limited amount of data that we keep up there on as a hosted feature service, and most of that is just like the assignments, stuff that doesn't directly tie into our water and wastewater assets.
Thank you, Becky. This question has come up multiple times with other customers of ours, so let's see what you can say about it. The question is that in your system, you can see that symbology change, and some of our customers have struggled with that because of the related tables and seeing what's been completed and what hasn't been completed. I know our product team for collectors working on this, but how do you manage that symbology in the completed versus not completed?
So in regards to like fire hydrant tests have been completed,
it's not a specific question as far as that, but I think that's it. And I know part of it is you were showing workforce. And so when a workforce assignment is completed, it can change the color in workforce. Do you also change the symbology on your map, your fire hydrant map?
No, we mainly just track in-service and out-of-service hydrants on the maps. That may be something we want to do in the future. The only symbology, I guess, that tracks the completed test is the one that I showed with concentric circles in the dashboard. So it just shows the most recent test, and I just used some arcade expressions to be able to demonstrate that based on the last service date.
Okay, great. Our next question has to do with work in the field. Do you have any problems with internet connectivity? And if so, how is that addressed?
So we initially had some issues, and we're still working through those. The initial setup with our iPads was they're Wi-Fi only, connected to a Wi-Fi router in the truck, which gave the limit. It was very limited in the fact that crews couldn't move more than 100 feet away from their trucks. to do work. And for a lot of our guys, that was an issue. And if you step too far away, you would lose that signal from the Wi-Fi router. So we've moved about half of our crews onto cellular iPads, and those have worked really well in the field. I haven't heard any complaints from that. We did a lot of troubleshooting. Well, I say we, but our IT did a great amount of troubleshooting on the Wi-Fi routers, trying to improve that. But we just found in the end that going to a cellular-based system was the best. So eventually we'll be moving, I think, all of our crews over to those cellular iPads. But as I said before, we got about half the team on it right now.
Okay, and do you ever have a need to take collector offline?
No, we haven't seen any use cases for that, but that's not to say that we won't in the future.
And then the workforce and collector integration in the field, have you had any challenges with that?
I'll let Andy voice his opinion on that. Just any issues from workforce to collector and back.
No, I haven't experienced anything. To touch on what Becky was saying, when we first got on the new iPad, we were hooked up with a router in the truck because we've got laptops in the truck. You couldn't take it very far from the truck or you'd completely lose signal. Now, since we're on the cellular plan, I mean, I haven't had any issues with it, and I've pretty much been all over our area 10 times and no problems.
Yeah, we don't have many or any dead spots within our service area because we're mainly downtown, Bowling Green area. We're in the city limits, so it's pretty well covered, which is good for us.
Yeah. So I know you mentioned that the field crews are using iPads. We had several questions about mobile devices. Are you using anything else or strictly the iPads in the field?
A lot of the crews, so when we were having Wi-Fi router issues, most of them would download it like collector directly on their personal cell phones, and it worked well there. And we would oftentimes hearing the guys say, well, it wasn't working on the iPad, so I just pulled out my cell phone and it worked great. It got me within, a foot of this manhole, whereas on the iPad, their signal was bouncing all over the place and it couldn't really hone in on where they were located. So a lot, which is great. I'm glad they're using their personal cell phones, but since we're moving to cellular, I think a lot of the guys are just relying on the iPads.
Right. Okay, and then now that you're digital and you're collecting so much data, you have your dashboards and it's easier to evaluate and analyze that. Have you discovered anything new about your system? For example, water loss or something that you didn't notice before? How's the data helping you?
I'd say it gives us a lot of visibility on the system in its current state. We've noticed some of these low GPM areas. I think that's been a surprise, and I think it's just leading us to do some further investigation. We have issues sometimes with contractors working out in the field, and they may pop open a valve cover and turn a valve, and who knows, even break the valve, and we don't find out till later. So it helps us pinpointing those areas, and then also maybe it just gives us double check on is Andy's equipment calibrated correctly. So it just, I think, brings those to light and helps us work through those issues a lot easier, being able to visually see all the data at once through the system.
Yeah.
Also, you can see the areas where you might want to upgrade the water system, the water lines. We might have a 4-inch feeding all these houses and they're building on that street. So it gives you a better incentive to where you can see areas where you need to upgrade.
Thanks, guys. We still have questions coming in, so I think we're going to spend a few more minutes on Q&A. So we talked about this process and how you moved from paper to digital. Can you give us an estimate of the time frame? How long did this take you to make that transition?
Well, like I said, it took us about a year's time to get our database migrated, and then we got just our, as we call them, foundational maps set up. So we'd already previously, before we moved to Esri, we had made a transition away from printing more paper maps. We were trying to emphasize the use of the online map that we had available. So that had already started in its process. So really, with the hydrant maintenance inspection forms that we had, or Andy used previously, it took about, I don't know, 6 months to move away from that because we had a lot of backlog on our inspection forms. I had an intern working to input that into our database and get its initial framework set up. And then, so we said by 2017, spring of 2017, we handed it over to Andy and he started inputting that data. So really, it was just a matter of a few months on that process. And in regards to our flushing program, our chief water chemist, he just sent me the spreadsheets for the flushing programs. And within a matter of a few days, we had the spring flushing program up and running. So it was a really easy process. The longest haul was taking those multiple spreadsheet tabs and putting it into one format that was usable in GIS, and to then input it into the workforce assignment schema. But really, that just took a matter of days, and then we were up and running.
Great. Another question is, do you have any hyperlinks in your GIS, for example, drawings of your plans? And then if so, did you have any issues doing that?
We used attachments really for like all of our as-built, and we still have some work to do on that. We created match tables in ArcMap and just inputted those and linked out all the as-built that were able to be linked. They're linked on our sewer side. We're still working on the water match table for our as-built, and so the crew guys can just click on the link right there and it brings it up. It's just tied directly into the database. So that works well, I think, in the field. And then also Andy, he can take current pictures of the hydrants, and those are also through related attachment tables. So that process really works well for us. I'm not saying that would work well for everybody, but it's done its job, basically, for us.
Okay. At the beginning of the webinar, you mentioned that you have a small utility ELA. Everything that you've shown today, was that included as part of your ELA, or did you have to purchase any additional products?
No, it was all within our ELA. All the stuff that we could access through the Water Solutions Gallery, basically the hydrant maintenance inspection and the valve inspection solution was right there to download. And since we were moved into the LGIM, it was just basically plug and play. The only outside services we had were with our partner True North Geographic. So we hired them to migrate our data, and then also they provided that script that just moves our data in the background for flow data on the hydrants.
Thanks, Becky, and thanks, Andy. I really appreciate you guys sharing your story today. It was a great presentation. Small announcement for those of you still on the line. We are planning our 2019 Esri Water Conference. It will be February 4th, 5th, and 6th in Nashville. So if anyone's interested in that conference, please check our website. We should be live maybe next week. We're launching with call for papers, etc. You can also reach out to me with any questions. Thanks again, you guys. Great presentation today.
Thank you.
Thank you all.